The aim of this talk is to give a brief overview of what GraphQL, Stiching and Federation are, and understand how they differ and know which one is best for you in your project. Just some background about me. I work as a full-stack developer on projects that typically involve Node, Python and Java. I've built and consumed REST APIs in past projects, but for the past 2 years I've worked on GraphQL-related projects, which has involved using GraphQL Stiching. I've worked in various industries for the last few years, mostly in government, but I've also worked in telecoms and also helped out in children's charities. And I've built many public-facing services that needed to scale. And I basically just love doing what I do. I like messing around with technology and code and playing around with stuff. I'm going to assume that you've at least come across GraphQL, but I want to make it clear GraphQL it's an alternative to REST. It's a very different animal. REST uses URL-based APIs based on verbs, and the applications often make multiple queries to fetch data from one or more sources and put them onto the screen. GraphQL is different. It uses a single endpoint, and the client application describes what it needs in a single query. GraphQL client applications send all the requests to a single endpoint, and it's virtually impossible to support multiple GraphQL backends. In GraphQL, data types are described alongside queries that the server will accept to read data and mutations that are available to change data. This information is all combined into a human-readable and machine-readable schema. Developers can use the schema as a contract between front-end and back-end, and it can also be used by tools to auto-generate scaffolding. Or for React, you can use it to automatically generate hooks. Servers and client frameworks use this schema to validate data being passed around, and GraphQL playgrounds can be used to read the schema and allow the user to try out queries and typically provide auto-completion when they're doing that. And if the developer uses a language like TypeScript, they can even get auto-completion and type checking in their code, which in turn can reduce errors and improve developer productivity. Like all technologies, GraphQL isn't always the best solution, and the pros and cons must be understood. As already described, GraphQL provides a clear schema that works well with developer tools. And requests tend to be efficient because the client only asks for what it needs and the server only fulfills what is asked for. In reality, this also makes writing GraphQL servers easier and more modular than REST-based solutions. There are drawbacks though. GraphQL is very different to REST, and it can take time for a REST developer to understand this and become productive. When I first worked with GraphQL, it all felt very different, and server-side development wasn't very clear to me at all. But once I'd had that aha moment, I now find development of GraphQL servers much easier and don't really want to go back. As the schema for an application grows, so does the code base, and this can cause multiple issues, and I'll come onto that in a moment. And the client libraries only tend to support a single GraphQL endpoint, unlike REST. So you can't really work with multiple GraphQL servers from a single client. It's virtually impossible, and it's certainly not recommended. So I want to focus on the issue related to complexity as the schema grows. A GraphQL schema can become complex very quickly. Anything other than the simplest application can balloon into a very complex schema. And all the code to manage this schema all sits in one code base, even though the data associated with different entities may be under the remit of different teams. Having multiple developers working on a single shared code base can lead to changes causing unintended side effects. If one team is in the middle of working on a new feature, it may block another team from pushing a new release into production. So with all the code sitting in one server, scalability may also become an issue. Different elements of a service may need to be scaled in different ways. Or it may be that one part of a service receives a much heavier workload than others, but you still have to scale the server up regardless. And finally, it may simply not be possible to have all your code in one place. A service may actually make use of external GraphQL servers. Imagine someone's building an application, not only uses your API to fetch data, but also they want to bring in data from third parties such as GitHub or maybe a weather service. You simply couldn't do this efficiently in a single GraphQL server. So in the case of a service consisting of a large schema involving multiple teams, it'd be better to break it up so that each team can develop and control its own part of the schema. In this model, a team managing users can manage their data, a team managing sensor data would manage theirs, and another team would manage reference data. This would give the teams the benefit of controlling their own code and their own data, and it also gives them the other benefit of controlling their own architecture as well. If a project uses information involving a third party, it needs to be able to concentrate on its data and combining that with the third party. So to address the issue of scaling schemas and to accommodate the need to break things up and work with third parties, the idea of GraphQL stitching came about. GraphQL stitching introduces the ability to stitch together multiple GraphQL backends into a single seamless GraphQL service. So with GraphQL stitching, a gateway, the gateway is responsible for two things. The gateway is responsible for combining the backends, the schemas in the backends, into a single schema. As we can see here, so we've got an example here where we say that a truck, we've got a fuel burn rate truck service that stores details about trucks, their names, and how quickly they burn fuel at different speeds. And we've got another service that involves planning things, and that service, it really wants to focus on the planning side of stuff, but it also needs to bring in information about trucks. So within the gateway, you introduce an additional schema that tells you how to combine the original schemas in the server. So in this instance, the gateway schema extends the truck inside a planner to say that it can include a truck name. And then the second job of a stitching gateway involves accepting the queries from clients and understanding how to split those queries up and send them onto the back end, and then combine the results it gets from those two different backends. So this actually involves creating resolvers within the gateway to describe those queries for the different properties and types that are being added and how to fulfill those. In the example here, you can see, I know it's very small type, but you can see that there's a query goes into the service that says it wants to get a plan, and it wants to know about the plan name and dates, and get a list of the trucks that are associated with the plan. And in that list of trucks, it wants to know the truck name. The gateway looks at the combined schema and that third schema, and it figures out that it needs to send a query to the burn rate service to the plan service to say, get me details of the plan, its name, its dates, and the details that the plan knows about the truck. And then it needs to know that it now needs to go and get the truck name from the other service, from the burn rate service. So it will then go and get that using the ID it's got from the first one, and then combine those together. So it has to have the gateway contains that intelligence to figure out how to split queries and how to combine the results. And I've used GraphQL stitching now for a few projects and come across a few pros and cons to this approach. On the plus side, stitching frees the service up to use multiple different GraphQL backends. Even if it's just used for an internal project, it allows the schema to be broken up into smaller chunks for the teams to manage. Code becomes easier to manage as a result, and the servers can be formed at multiple servers, and that allows for more flexible scaling. If you have one GraphQL server that has been put under a heavy load, you can now horizontally scale just that particular server. The gateway itself doesn't do very much work, and if it was busy as well, it could also be horizontally scaled because it's stateless. But these benefits come at a cost. Yet another schema gets introduced into your project, and that needs to be maintained, and it requires resolvers to figure out how to go and fetch that and join that data. And it's been seen that stitching generally assumes when you're doing that join that data can be fetched using a simple top-level query, and that's not always the case. In some situations, I've come across complex nested schemas, and in those you've had to pass the parameters into a nested property and grab a nested type or nested property, and that is incredibly difficult to do and difficult to manage. Generally, once a resolver is set up, it doesn't require too much change, but you will find sometimes that if someone changes the back end, or you want to make use of a new field, you will need to go and update the gateway and make sure you coordinate that gateway with the back ends that it's talking to. So this brings me on to federation. Apollo, one of the major players in GraphQL client-server software, works with companies and recognised the need for companies to break up their schemas into more manageable chunks. Very early on, Apollo worked and developed the GraphQL tools library to provide the stitching functionality that we described. But then later it developed federation because it wanted to try and do a better job. The Apollo was so confident that federation was better that they actually deprecated their support for stitching and told their developers that they should switch to federation and drop stitching. In hindsight, this was not a good decision, as federation is not a one-size-fits-all solution and it has its own limitations. It would appear that Apollo, though, have realised this, and they've handed over control of the stitching libraries to an organisation called the Guild recently. And they've been very actively working on the code base for GraphQL tools and stitching, and have produced extremely good documentation and support, are actively working on that and helping people. Federation takes a different approach to stitching. Federation uses the concept of enhancing the GraphQL schema language with a set of new directives to define how types, properties, queries, mutations, how they relate to each other across multiple schemas, or even just be better describe what's in that schema. These enhancements to the schema allow the federation tools then developed by Apollo to analyze incoming requests into a gateway and figure out how to fetch and combine that data without having to write handwritten resolvers. It machine generates those solutions. But unlike stitching, which relies on the schema in the gateway, this relationship data and this information has to sit inside the backends that you're talking to. So this is a fundamentally different approach. On the surface of it, it sounds similar, but it is a fundamentally different approach. And again, it comes with its own pros and cons. On the plus side, the directives that have been added provide a greater insight into a schema and the relationships and how entities work within it. And the fact that that joins are machine generated based on a declarative syntax leads to simpler code and reduced boilerplate because you don't have to write so many resolvers. And if a service includes federation, if you're working with a third party that includes federation in their schema information already, it makes it much easier to integrate with them because you don't need to write your own stitching code. You can just use the federation toolset. But like stitching, this comes at a price, and federation it's not a one-size-fits-all solution. The federation directives were created by Apollo in isolation from other server vendors. So when they first released support for federation, nobody else supported the federation schema directives. So I worked on a project a year ago, and one of the servers I was integrating with was not an Apollo server. So I couldn't use federation because it just wasn't supported. And even though at that time Apollo were telling me, deprecate your stitching code, use federation, you couldn't. You simply couldn't. I know other frameworks have started to support federation, but this has been largely through these third-party plugins, or even kind of additional modules or middleware layers. And these come with their own kind of risks. The biggest risk is that if the vendor changes code within the GraphQL server, it may break the module. So it may be that you're stuck in a particular version of the server and you can't upgrade until the module does. But maybe the biggest blocker is, in order to use Federation, all the backend services that you talk to must support it. If even one of them doesn't, then you are starting to look at how to create a Federation layer in front of it. And lastly, one thing that's not discussed so much is that the services within a kind of a federated solution, the backend services tend to be more tightly coupled. It's more likely that if you make a change in one backend service, that you'll need to make a reciprocal change in the other service that it's talking to. So you still get into this realm of having to make changes in multiple places and having to coordinate your releases. So if you want to be not so tightly coupled, if you want to have a bit more freedom, then you may not want to look at that. So the question that most people ask is, which one should I use? And for any project that involves a server that doesn't already support Federation, I would probably consider Stiching. It may be possible to put a Federation middleware layer in front, but that is likely to complicate the solution further, and you have to ask the fundamental question: what benefit is that giving me over Stiching? If you want to build something where you don't want to be too tightly coupled to the backends that you're working with, and you don't want to have to coordinate your releases with theirs, then again, I would consider Stiching. But if you are working on something where you have, if you want to break up, if you have a schema already, you want to break something up into smaller chunks to manage it, which is why Apollo created Federation in the first place, then Federation is most likely the better solution for you. Or if you're working in a solution where all the backends already support Federation, then it's really a lot simpler to do the integration work by just using Federation and not have to write a stitching code. One thing I would mention is, whilst working on this talk, I did come across a relatively new piece of middleware that came out at the end of 2019, I think, from a company called Zevia, I think they're called. They've produced a piece of middleware that sits within a Node application that aims to let you add Federation to an API that doesn't support it already. So it may be that you're working with a service that doesn't support Federation and you have no control over it, or maybe that you have one but that you don't want to change it too much and you'd rather build something that's slightly less risky. And so they've produced a solution for that. Now, on the face of it, like most solutions, it promises lots of things, and it seems to say that all you do is you enhance your schema a little bit here and a little bit there, and you added this extra layer, and it solves all your problems. But I'm pretty sure it's not that simple. But one of the things I want to do is I'm going to do the next few weeks is I'm going to be finding out, does it actually complicate your architecture needlessly? Does it actually provide the benefits that it promises? Because if it is a simple piece of middleware that you put in with a little bit of declarative information, and it automatically helps you to stitch complex schemas together, then yes. But if it's just another layer that still requires you to write the same sort of code as you would for stitching, then why wouldn't you just go for stitching? So, I hope that's helped you understand a little bit of the differences between Federation and stitching, and understand which is the best approach for your service. If you've got any suggestions for changes to this talk, or if you've got any ideas for improvements, if you've got any questions, please get in contact with me. My email address is here, my Twitter name is there. I do plan over the next few weeks to start writing some simple demonstration projects within GitHub to show how to do stitching for a simple schema, how to use Federation for joining two different schemas, and also, as mentioned, try out this proof of concept for adding in the Federation middleware in front of something that doesn't support Federation to find out if it provides the benefits that it promises. So thank you for listening to me. Thank you for listening to the presentation today, and any feedback, please feel free to contact me. Thank you.